This is Lesson 6-3 from the Algebra Readiness textbook. Have out your notes packet, a sharpened pencil, and a calculator for today's lesson. Work these review problems independently and continue the video when you're ready to compare your answers to mine. For the first question, we're reviewing proportions. If you can solve 12 math problems in 45 minutes, how long will it take you to solve 20 math problems? Well, you can set up a proportion. First, you would define your ratio as problems over minutes. The first ratio would be 12 over 45, noting that 12 is the number of problems and 45 is the number of minutes. Then I would set up 20 problems over m. A proportion is two equal ratios, so I need to make these equal. So I use cross products. 45 times 20 is the same as 12 times m. 45 times 20 is 900. So what number times 12 equals 900? I simply take 900 divided by 12, and I get 75 minutes. The next problem, solve the proportion 2 to 33 and x to 198. This time, you don't have to really set up the proportion. It's given to you, and you solve using cross products, and you get x equals 12. Or if you knew that 33 times 6 gave you 198, you could have taken 2 times 6 and made equivalent fractions. The next one, that means that you're going to have a problem like each of those on your upcoming test and quiz. Mr. Adolphson's science class, 20 out of 33 students are going on the field trip. In Miss Barrett's class, 16 out of 21 students are going. Is the ratio of students attending the field trip the same? In order to figure out if they are the same, we have learned a couple methods. We can either put the ratios in simplest form and compare, or you can see if their cross products are equivalent. So I started off by writing the ratios, 20 to 33 and 16 to 21. Then I multiplied cross products to see if the cross products gave me the same answer. 528 is one of the cross products, 420 is the other cross product, and I can see that those are not the same. And so the answer is no, and this right here is my explanation, or I could say cross products are not equal. Simplest form is not equal. Today's learning target is to use ratios of corresponding sides to identify similar figures. There's a lot of new words in here. We know what ratios are, but we have not learned about corresponding sides, and we don't know about similar figures. So we've got a little bit of work to do. Let's take some notes. In your notes, the first thing you're asked is to write down the definition of similar. Similar figures have the same shape, but not necessarily the same size. So here are some examples. You can see that there's two sailboats. They are exactly the same, but one is smaller than the other. So they have exactly the same shape, but not the same size. Now, photographs, maps, blueprints, those are all examples of similar figures. Here is a mathematical example where you have triangle SUE is similar to triangle ROB. And we'll talk about that in a little bit. There's also corresponding parts. Corresponding parts are corresponding really means in the same location. So like for example, my right arm is in the same relative position on my body as your right arm is on your body. The same thing is true with my nose and your nose. They are in the same relative position to each of us. And our eyes are in the same relative position on each of us. Well, the same thing is true for shapes. Corresponding sides of two shapes are in the same relative position, and corresponding angles are in the same relative position. So let's start by identifying corresponding parts. Let's look here. EU. I notice that EU is the shortest side of triangle SUE. Which side on ROB corresponds to UE on the smaller triangle? Well, the smallest side in ROB is right here, OB. So those two are corresponding. Let's try another one. Side SU is the medium shape. Notice it also makes up that 90-degree angle right here. So which side on the other triangle matches? Well, it would be the other medium side. It also is the side that makes up that right angle. That right angle is also a corresponding angle. Angle U corresponds to angle O. They're in the same position. Side SU corresponds to side RO. They're in the same relative position. Okay, let's try another one. The last one then would be, this is a bright blue, ES. Do you see that ES is the longest side? It's also the side across from the right angle. So which side in the larger triangle is in that same relative position, across from the right angle and the longest side? There it is, RB or BR. Good. So now I want to show you something else that's neat. Go back to where I highlighted in yellow. In this triangle, it's UE. I want to show you something. Triangle UE, SUE is similar to ROB. UE matches with OB. Look at this. The way that the similarity is given to you in the problem, triangle SUE is similar to triangle ROB, those vertices always match your corresponding side. So the last two from U to E matches or corresponds to OB. The same thing is true with SU in orange, and then the orange side RO on the picture. Okay, take a look at the orange sides, SU and RO. Now go up to where it's listed under the example. SU are the first two digits, RO are the first two digits. Do you see that? And then let's look at the last blue part. SE and RB. That's the blue ones. Okay, now look. SE and RB. See how they're in the same position in the math statement as they are in the picture. That can help you. It also means that angle S and angle R are in the same spot, meaning they're both the smallest angle. Take a look. Look right here, angle S. Boy, that's a pretty small angle, isn't it? Look at angle R. It's exactly the same. It's also the smallest angle on the larger triangle. The same thing is true with angle U and angle O. Angle U, 90-degree angle. Angle O, 90-degree angle. And lastly, angle E and angle B also match. So you can use actually the way that they list the similar triangles or figures to help you figure out which sides are in the and which angles are in the same position. Okay, let's practice. Triangle CAT is similar to triangle DOG. What is the measure of angle D? Well, how in the world am I supposed to know that? Well, let's try. Well, what angle is the, let's label the sides, small, medium, and large. This side, CT, is small, this side is medium, and this side is the longest. Small, medium, long. Now I know which sides are corresponding. So the small side corresponds to the small side. Now the same thing is true with the angles. So the angle made up by SL is the same as the angle made up by SL here. Now, similar figures have the same angle measure. So that means this angle measure is 50 degrees. Corresponding or similar figures have equal angles. Now, how do we find this last angle? ML, side ML, and side ML are both blank in angle A and angle O. But you learned in 6th grade that when you add all of the sides of all of the angles in a triangle, that they equal 180 degrees, didn't you? So 50 plus 95 is 145. So 180 minus the 145 already here gives me 35 degrees. So that means angle O is also 35 degrees. And lastly, angle D. Well, angle D must match angle C. It's the wider angle. And so 95. Okay, so angle D is 95, angle A is 35. Let's try another one. Matching the corresponding sides, which side of triangle CAT corresponds to side DO of triangle DOG? Now hold on a second. Let's try to do it without the picture. What side corresponds to DO? DO is the first two vertices of triangle DOG. So DO corresponds to the first two sides in CA. Because they're the first two listed. And so you can use that as a shortcut. You would say side, well, that's maybe not in highlighter, side CA. Okay? So we need to write a couple things down in our notes. I think that under our definition of similar figures, we need to make sure we write in there that similar figures have, let's see, similar figures have proportional sides so get the word proportional in there, proportional sides, and that's what we're going to dial up next, and equal angles. Make sure we get that written down. That's important. Not just write it down, but that's one of those for the memory bank in your brain. They have to have proportional sides and equal angles. Well, proportions, we know how to solve those. So guess what we're going to do? First, we're going to figure out, also, before I go on, this. Do you see this little squiggly line? That is the sign for similar to. All right, so knowing that two angles, or that all the angles must be equal and the sides must be proportional, I can use that as a test to tell if two shapes are similar. So sometimes they look like they're close, but they're not actually. Here's what you do. You look at the sides, especially when they're rectangles, then you pick the short side and the long side. I like to color code it. You can just write short and long, or however you like to do it. So short, long, short, long, short, long, right? So now all you want to do is see if they form a proportion. Well, how do you check that? You see if the ratios are equal by checking their cross products. So 4 to 10, is that equal to 2 to 5? 5 times 4 is 20. 10 times 2 is 20. That means that rectangle J is similar to rectangle K because sides are proportional. So let's pick either one of them. Let's use 2 to 5. 2 to 5, does it equal, now again, short to long, 5 to 12? Well, 5 times 5 is 25. 12 times 2 is 24. So are J and K also proportional to L? No. Because they do not have proportional sides. Now we can also, try this one. We can also use this information to find the length of a missing side. So if I have two sides, again, I'm going to start off by labeling the short side, and then I'm going to label the long side. And then it helps me out, so I'm going to define my ratio first. Short over long. Now the short side of the first figure is x. The long side is 16. The short side is 18. The long side is 24. Now, I'm told that these are similar. See this? They are similar. So that means the sides are a proportion. So that being the case, you simply solve the proportion. Go ahead in your calculator and type 18 times 16, and I get 288. Well, we know that cross products are equal. So what number times 24 equals 288? And the answer is 12. So the length of x is 12, whatever the units are. Okay? All right, now I'd like you to pause the video. And this time, I want you to find the missing measures of these two similar figures. I want to start off, maybe I'm going to help you with the first one, so that because it's a triangle and not a rectangle. I label the sides short, medium, and long. Short, medium, and then long. I identify the sides first, so that way I'm not having to rethink each time. Okay, then notice I did medium over short. So then when I was trying to solve for y, then I did long over short to solve for z. So I had to do two separate equations or two separate proportions to find the two missing sides. All right, now pause the video, try to set up a proportion, and then continue when you're ready to compare. All right, for the first one, I did y over 15, orange over blue, and then 63 over 27, orange over blue, and I solved the proportion, and I got 35 centimeters. Then for side Z, the long side, I did pink over blue and pink over blue, 50 over 15 and Z over 27, and I solved it to get 90 centimeters. Moving on, indirect measure. Now we're going to move into how we use various ways of using proportions in math class. One of the things that we're going to talk about is indirect measure. You're going to want to draw a picture for these. Indirect measure is used in real life to measure distances that are too difficult to measure directly. Like, you can't really measure the distance across the Grand Canyon. You can, however, measure the distance using indirect measurement. A building is 70 feet tall. So I'm going to draw a picture of a building. Here's my building. It's 70 feet tall. It casts a shadow that is 150 feet. A flagpole nearby casts a 60-foot shadow. Draw a diagram. Use similar figures to find the height of the flagpole. So my flagpole is what's missing. Now, do you see that the shadow length corresponds to the shadow length? The height of the building and the height of the flagpole are corresponding. They're in the same position. Do you also see that technically you have a triangle because the sun is up here, shining down, creating this shadow. And the shadow, like this, the way the sun hits it, makes two similar figures. So I have similar triangles here. Now I can set up a ratio of height over shadow. The height of the building is 70 over the shadow is 150. The height of the flagpole is X over the shadow, which is 60. In your calculator, now you're just going to solve that proportion. That's the easy part. The setup is what we're really working on today. and seeing all the different ways they might ask you to apply it. So the height of the flagpole is 28 feet. Make sure you are labeling. Also, make sure you're drawing pictures. All right, pause the video and try to draw a picture of this one. It's similar to the, no pun intended, it's very much like the last problem you did. Okay, so a tree casts a shadow that is 10 feet long, so label it 10 feet. A 5-foot tall woman casts a shadow that is 4 feet long. The triangle shown, the triangle shown for the woman and her shadow is similar to the triangle shown for the tree and its shadow. How tall is the tree? So this is what I'm wondering. So the height of the tree corresponds to the height of the woman. The shadows are always corresponding to the other shadow. Again, this creates a similar figure because of the way the sun comes down at the same angle. So we're going to go height over shadow. For the tree, it's x over 10. For the woman, it's 5 over 4. Then when I solve it, I get 12 and 12.5 feet is the height of the tree. Now, this isn't the only way. A scale drawing is an enlarged or a reduced drawing that is similar to an actual object or place. The ratio of the distance in a drawing to the corresponding actual distance, so the actual distance is the corresponding length, is called a scale factor of the drawing. We see scale factors on maps. We call them a scale. And the scale can be used to set up a proportion and find the actual distance. Now, one type scale drawing is right here in this house. The scale of a house blueprint is 1 inch equals 4 feet. What is the length of the 22-foot covered porch on the blueprint? So I've got this porch right here. See it? And it is 22 feet in real life. So we're going to go image and then actual, like in actual life. I'm going to use 1 inch is 4 feet, right? Equals, now 22 feet goes in the bottom. Oops, I wrote feet and I meant to write 22. I want to know how many inches is that in my blueprint. So 22 times 1 divided by 4 gives me 5.5 inches in the blueprint. All right, what is the width of the 50-foot house on the blueprint? So the entire house, right here, from one end to another, is 50 feet. So how big or how many inches is that? I can show you. 1 to 4, 1 inch is 4 feet, equals x over 50 feet. And then you solve it. And you get 12.5. So it's 12.5 inches. If you would measure it with a ruler, that distance is 12.5 inches on the scale drawing. Okay, so blueprints is one way. Another way is on an actual map. I want you to pause the video now and try to work these problems using the picture given. Then when you're ready to compare your answers to mine, continue the video. All right, the scale of the map is 1 to 40. You should have gotten 60 and 1.875 inches. 3-part ratios. I want to quickly touch on this so that you've seen it. A special cereal mixture contains rice, wheat, and corn in a ratio of 2 to 3 to 5. You're thinking, what? You can have 3-part ratios? You bet you can. So if a bag of the mixture contains 3 pounds of rice, how much corn does it contain? Well, one method is to ignore the wheat column altogether. So we're just going to ignore this column because I didn't ask anything about the wheat. And then set up your ratio or set up a proportion of, in this case, the rice is 2 to 3 and 5 to X. See that? And solve it. And you would get 7.5. Okay? The other way to think about it is to, again, set up your ratio of going, okay, I want rice to corn. Okay, rice to corn is 2 to 5. So rice to corn in my next one, because I have 3 pounds of rice, is 3 to X. Again, 15 divided by 2 equals 7.5. Okay, so you can use, even though it's a 3-part ratio, the order of the given ratio. So let's focus up here. The order of the given ratio is in the order it's written up here. Rice first, then wheat, then corn. All right, let's see if you can do one. A rancher keeps horses, cows, and dogs. So horses first is the first number in the ratio. Cows is the second. Dogs is the third. He keeps those on his property in the ratio of 2 to 15 to 1. If the rancher owns 105 cows, how many dogs and how many horses does he have? It's going to take you 2 proportions. Pause the video, try it, and then compare your answer to mine. Hopefully you got 7 dogs and 14 horses. All right, time for your